Let's look at a few examples of IRR. So here we have Patriot Theaters. They're looking at a rest and drive-in, and it's going to cost $500,000 today. And then after that, $75,000 a year forever with the first cash flow in 1 year. Would they choose to expand? Do they want to take this project if the cost of capital of the project is 12.5%? So figure out the IRR, and if it's greater than 12.5, take the project. If it's less than 12.5, reject the project. Well, here's an interesting case where you put in 500,000 and then you get 75, 75, 75, 75, 75, 75, 75 forever and ever and ever. So we've got our cash flows. We know our cost of capital is our benchmark. And now what we need to do is find the IRR, but we can't use the IRR function in this case because we can't just enter in all the cash flows because they go on forever and ever and ever. But we have other tools that we can use to solve this problem. Remember that by definition, IRR is the present value, or is the discount rate such that the present value of all the expected cash flows is equal to 0. Well, in this case, we know that C0 is equal to negative 500,000, and we recognize that C1, C2, C3, C4 forever and ever and ever is a fixed perpetuity. First cash flows in 1 year, it stays constant forever and ever and ever. So we know that the present value of C1, C2, C3, C4 forever and ever and ever is just C over the IRR. C over IRR is equal to 75,000 over IRR. So when we put it all together, if we want to find the IRR, it's the discount rate such the present value of all the cash flows is equal to 0. So what do we got? We got negative 500,000 at time 0, and then after that we have an infinite stream of 75,000s. So we want to find IRR such that 0 is equal to negative 500 plus 75,000 over IRR. IRR in that case is the discount rate such the present value of all the expected cash flows with this project equals 0. Well, all you have to do is add $500,000 to both sides, and then divide both sides by 500 and multiply both sides by IRR, and you find that the internal rate of return of this project is 15%. If you discount all the expected cash flows by 15%, you wind up with a present value of all those adding up to 0. Since 15 is greater than 12.5, accept the project. What are some of the strengths of the IRR and the IRR rule? Number one, it's appealing because it's a rate. People like rates. It means something. If you say the IRR on this project is 14.3%, it means something. It recognizes the time value of money. When we're trying to compute it, when we're calculating it, $100,000 expected in a project in 1 year gets treated differently than $100,000 in 5 years. It recognizes risk. Why? Because you get the IRR, and what are you comparing it to? The cost of capital, which is based on the risk of the project. How risky is the project? Stocks and bonds with the same level of risk. What's their expected return? And that's what you compare it to. And the rule is based on economic principles. It's what I just said, that you have a project, you compute the IRR, that is the project's expected return. You compare it to the expected return of stocks and bonds with the same level of risk, and those are determined on well-functioning markets. And so the rule is accept if the IRR is greater than cost of capital and reject if it's less, and it's economic principles. It's not managers saying here's our threshold, here's our threshold. If you have conventional cash flows, and again remember that's negative at time 0 because that's when you put in your investment, and then after that all the cash flows are positive or 0 with at least one positive, then the rule always leads to the right decision. If you have a project that would create value, it will have a higher IRR than the cost of capital and you'll accept it. If you have a project with a lower IRR than the cost of capital, that you would reject it. But when you have a project that would destroy value, one where the value of what would go in is more than the value of what would come back, it'll have a lower IRR and it'll be rejected. So IRR and NPV lead to the same conclusions when cash flows are conventional. What are some of the weaknesses? Key weakness, when cash flows are not conventional, IRR is not appropriate. Sometimes there may be multiple internal rates of returns. Sometimes you may not have any. There may be no rate such that the present value of all the expected cash flows equals zero, or you might have multiple rates. Sometimes it can lead to the wrong decision. Sometimes you have a project with positive NPV and you'll reject it. If you go ahead and compute the IRR for this kind of project, you'll see that it has a very low IRR, and you'll say no, but if you actually computed the NPV, you'd realize it would create value. You can get the opposite, where you can have a project that if you computed the NPV, you'd realize, whoa, this is a really bad one. It's expected to destroy value, but because the cash flows aren't conventional, when you go and figure out the IRR, you can wind up with a very high IRR, and you'd wind up accepting the project. So here's 3 important cases when the IRR rule is not appropriate and should not be used. Number 1, if you have positive expected cash flows and then negative cash flows. Again, there's nothing inherently wrong with a project like this. This is just one where you get your money up front and then you have to pay it back later. You just can't use IRR to make a decision as to whether it's a good or bad project. If you have a project where cash flows flip sign more than once, it starts out negative, then positive, then negative. Again, nothing inherently wrong with a project like that. You put money in, you operate it for a few years where it's bringing in lots and lots of money. Then the last year requires, shutting down, cleaning up, and that's negative cash flow. But again, when you put it all together, it could turn out to be a great project. You just can't use IRR to tell you that. And finally, if you have expected cash flows that never flip sign, so again, you might have a unique project where all the cash flows are always positive, or you might have one where all the cash flows are always negative. Clearly the positive is great. I mean, who wouldn't want to do a project where you just kept getting money? But IRR can't be used to tell you that. Same thing if it's all negative, it's not a very good project if you're just constantly paying out money and nothing's ever coming back to you. But you can't use IRR to tell you that. So let's look at a couple of cases. And this is about not whether it's a good project or not, but whether it's appropriate to make that evaluation based on IRR and the IRR rule. A is looking good, negative and then a bunch of positives, classic conventional. How about B? Negative, zeros and 1 positive, looking good. How about C? Negative, then a bunch of zeros and a positive, looking good. But notice C is a bad project. You put in $100 and then 4 years later you get 40 back. What we're saying isn't that, yes, check, it's a good project. It's check, we can use IRR to evaluate it to tell us that it's not a good project. How about D? We get 100 and then 4 years later we pay back 1. That is not conventional. But again, that's a great project. I get $100 today and 4 years later I pay back 1. It is a great project. I just can't use IRR to tell me that. How about E? Negative, then 3 positive, looking good. But a negative, cash flows are not negative, followed by all non-negatives with at least 1 positive. Can't use IRR. How about F? Put in 100 and then get 10 back every year. Certainly you can use IRR because it's conventional. Not a very good project. You put in 100 and you get 10, 10, 10, and 10. If you did the NPV on that, at a reasonable cost of capital of, let's say, 10%, your NPV is going to be somewhere around negative $65, somewhere around that. And so you can't use IRR. How about G? Positive, 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 positive. Can't use IRR. Great project. Who would want to get $40 every year for, 5 years at 0, 1, 2, 3, and 4? Just can't use IRR to tell you that. And finally, project H is a no because you've got a bunch of positives followed by a negative. Basically, anytime that you see that there is a positive number, anytime that you see that there's a positive number at time 0, or you see a negative number out here after time 0, you know that you cannot use IRR to evaluate that project.